senior high school students. I'm Teacher Abby. Welcome to Physical Science Week 7. Today we'll be having an exciting discussions and activities. So, what are you waiting for? Get ready with your notebook and pen for your key takeaways. In today's sessions, you are expected to use simple collision theory to explain the effect of concentration, temperature, and particle size and the rate of reaction. Define catalyst and describe how it affects the reaction rate. Specifically, you should be able to explain the requirements of the collision theory, discuss the effect of concentration, temperature, particle size, and catalyst on the reaction rate. Cite examples of chemical reaction in the household and in the community. So, are you excited? To begin with, let us do the quote and unquote activity. In 3 sentences, explain the saying, "Nothing is permanent in this world except the word change." I'll be giving you 3 minutes to accomplish this. So, are you done? As the famous saying goes, nothing is permanent in this world except the word change. Everything that surrounds us undergoes transformation. From the food that we fill our stomachs, to the basic necessities that we use every day, to the stars and heavenly bodies that light up our skies, and even you. Yes, you. You undergo a series of transformation every single day, since well before the beginning of the recorded history. Natural substances have been purposely changed into new products. The changes brought about by humans for their own use include conversion of natural clay into pottery, limestone rocks into building materials, and metals like silver and gold into jewelry pieces. In this lesson, you will investigate how these changes occur, how fast or slow these changes happen, and what are the examples of these changes that we see in our daily lives. Since these changes are inevitable in our world, might as well understand them well. Learning about the chemical changes will be fun and exciting. To begin our discussion, let us first test your previous knowledge about the topic. Let us do the pretest. Let's try this. Choose the letter of the correct answer. There will be 5 questions that you have to answer. Number 1. Which of the following is a postulate of the collision theory? A. Collision leads to a chemical reaction. B. Effective collision leads to a chemical reaction. C. Collisions lead to a chemical reaction. And D. Very few reactions involve particle collision. Is it A, B, C, or D? If your answer is B, you are correct. Effective collision leads to a chemical reaction. For question number 2, food is refrigerated to slow down its decomposition caused by bacterial action. Which best explains this situation? A. The decrease in the number of particles possessing activation energy. B. The decrease in the surface area of the food upon refrigeration. C. The introduction of an alternative pathway for the decomposition to take place. And D. Lowering of the heat of reaction of the decomposition reaction. Is it A, B, C, or D? If your answer is B, you are correct. The lowering of the heat of reaction of the decomposition reaction. Now, let's proceed to question number 3. Which of the following generally true for a chemical reaction with a large activation energy? A. It will only occur at low reactant concentrations. B. It will only occur at low temperatures. C. It will proceed at a fast rate. And D. It will proceed at a slow rate. Is it A, B, C, or D? If your answer is B, you are correct. It will proceed at slow rate. For question number 4. Which of the factors listed are required for a successful collision? 1. Catalysts are present. 2. Orientation of particles are favorable. 3. Reactant particles collide. 4. Sufficient energy is applied to the system. The choices are, for letter A, 1 only. For letter B, 2 and 4 only. For letter C, 1, 2, and 3 only. And for letter D, 1, 2, and 3, and 4. Is it A, B, C, or D? If your answer is B, correct. It is the orientation of particles are favorable and sufficient energy is applied to the system. For the last question, number 5. What happens to the reaction system if its temperature is increased? A. The more collisions occur, but the collision energy is the same. B. The more collisions occur, resulting in a higher reaction rate. And C. The same number of collisions occur, but with a greater collision energy. And lastly, the same number of collisions with the same collision energy. Is it A, B, C, or D? If your answer is B, you are again correct. The more collision occurs, resulting in a higher reaction rate. How did you find the test? Don't worry if you get a low score. This only means that there are more things that you can learn from this lesson. So, have fun! Let's have a recall. As I was wandering the streets, I have here listed materials that undergo certain changes. Help me identify as to what kind of changes do these undergo, physical or chemical change. Let's do this activity 1. First is the crushing of a can. Does it undergo physical change or chemical change? The answer is physical change. The next one, baking a cake. Does it undergo physical change or chemical change? The answer is chemical change. Next one, iron resin. Does it undergo chemical change or physical change? The answer is chemical change. Mixing sand with water. Does it undergo physical change or chemical change? The answer is physical change. The last one, wrapping banana. Does it undergo physical change or chemical change? The answer is chemical change. How do you find the activity? Is it exciting? Have you recalled the differences between the physical change and chemical change? Refreshing your concepts on this is important, for we will focus mainly on chemical reaction. So, it is important to know which one is and isn't. Keep this in mind that a physical change is the one that involves no change in a fixed composition of the substance in question, only the rearrangement of the molecules with respect to one another. There are some examples of physical change, like breaking glass, mixing candle, shredding paper, folding paper, melting ice, chopping wood, cutting hair, dry ice sublimation, boiling water, and breaking egg. However, chemical change or chemical reaction occurs when the composition of a substance is changed into another substance. It involves change in color, odor, taste, and release of gases. Here are some examples of chemical change. Rusting iron, burning wood, metabolism, cooking an egg, baking a cake, electroplating, rotting banana, vinegar and baking soda mixture, fireworks, and chemical battery. Now, let us focus on chemical reaction. Do these reactions always happen instantly? If not, how long does it take before a reaction to occur? Let's begin with this by performing the activity entitled The Chemistry of Finding the One. They say that labs happen the same way chemical reactions occur. Let us get to know this how by watching the video. Enjoy!
Meet our chemist, Harriet. She has a chemical reaction that needs to occur more quickly. Our chemist has some processes at her disposal that can help her speed up her reaction, and she knows of 5 ways. And to remember them, she thinks back to her days as a high school student and the day she got a date for the dance. Harriet was in high school studying between classes. She had lost track of time and was going to be late to class. Unbeknownst to her, Harold, who was just around the corner, was running late too. They both sprinted to class, and as it happened, sprinted directly into one another. Now, this was no small collision. They ran squarely into one another in such a way that he knocked the books right out of her hand. "I'm sorry," he said. "Let me help you with your books." He kindly helped her recollect her belongings and politely offered to walk her to class. And you'll never guess who went together to the dance later that year. Yep, those two. So as we can see from this example, the key to getting a date for the dance is to collide with someone and knock the books out of their hands. Now, you're probably already aware that not all collisions lead to dates for the dance, thankfully. The collisions must have 2 important characteristics. 1, correct orientation that allows books to be knocked from one's hands, and 2, enough energy to knock the books out. Shortly after this incident, Harriet decided to tell me, her chemistry teacher, all about it. I noticed some interesting parallels between her story and chemical reaction rates, which happened to be what she was studying in the hallway the day of the collision. Together, we decided to set out on 2 missions. Harriet wanted to help all chemistry students and chemists remember how to speed up the rate of chemical reactions, and I, being the nice guy that I am, decided to make it my mission to help create educational environments in which more book-dropping collisions can take place to increase future chemists' chances of getting a date for the dance. In order to facilitate this improved dance date-getting process, I propose 5 changes to all schools that parallel Harriet's 5 ways to increase chemical reaction rates. First, I propose that we shrink the size of the hallways. This will make it more difficult to safely navigate the hallways and will cause more collisions than in larger hallways. And by increasing the number of collisions, we increase the likelihood that some of those collisions will have the correct alignment and enough energy to create a date to the dance. Now, chemically speaking, this is equivalent to lowering the volume of a reaction vessel or a reaction mixture. In doing so, the individual particles are closer together and more collisions will occur. More collisions means a greater likelihood that collisions with the appropriate energy and configuration will happen. Second, I propose increasing the overall population of the school. More students equals more collisions. By increasing the number of particles available for collision, we create an environment where more collisions can take place. Third, we must reduce the time allowed between classes. Heck, let's just cut it in half. In doing so, students will need to move more quickly to get from one class to the next. This increase in velocity will help make sure collisions have the appropriate amount of energy necessary to ensure book dropping. This is analogous to increasing the temperature of the reaction mixture. Higher temperature means particles are moving faster. Faster moving particles means more energy and a greater likelihood of reaction causing collision. Fourth, students must stop traveling in packs. By traveling in packs, those students on the outside of the pack insulate those in the middle from undergoing any collisions. By splitting up, each student has more area exposed that is available for a collision from a passing student. When particles travel in packs, the surface area is very small, and only the outside particles can collide. However, by breaking up the clumps into individual particles, the total surface area is increased, and each particle has an exposed surface that can react. Fifth, and finally, we hire a matchmaker. Is this colliding and book dropping too violent? Is there an easier way to get a date that requires less initial energy? Then a matchmaker will help with this. The matchmaker makes it easier for a couple to get together by coordinating the match. Our matchmaker is like a catalyst. Chemical catalysts function by lowering the activation energy. In other words, by lowering the energy required to start a reaction. They do this by bringing two particles together and orienting them correctly in space so that the two can meet at the correct configuration and allow a reaction to take place. So, to sum up, if a future chemist wants a date for the dance, he must collide with another person and knock the books out of their hands. And if a chemist wants to make a chemical reaction occur, the particles must collide in the correct orientation with an appropriate amount of energy. And both of these processes can be accelerated using the 5 methods I've described.
From the video that you have watched, let us answer the following guide question. First, how did Harriet meet Harold? Yes, they collided in the school hallway. What are the two important characteristics of collision in order to get a date or to have a chemical reaction? Yes, reactants must be in their proper orientation, and molecules must possess enough energy to initiate reaction. The third one, are the ways of producing chemical reaction the same as the way Harriet got a date in the school dance? Yes, they have similarities. What are the ways they propose in order to speed up the rate of chemical reaction or getting a date in a school dance? Here are the ways. First, shrink the container or increase concentration. Increase the size of the number of particles. Speed up particles by adding heat. Break up lumps into individual particles and use catalysts. By the way, what are catalysts? How are they related to the activation energy of the reaction? Catalyst is a substance that increases the rate of reaction by providing alternative pathways for the reaction to occur. This is one with a lower activation energy. Did you find the link from our video discussion? Now, let us elaborate those concepts you gathered from here. Reactions proceed at different rates. Some are slow, while others are fast. When a reaction occurs slowly, it is described to have a low rate of reaction. If a reaction occurs fast, it has a high rate of reaction. The energetics, mechanism, and rate of chemical reaction are explained by the collision theory. According to this theory, for a chemical reaction to proceed, there should be an effective collision between the reactant particles. For this to happen, two requirements should be met. First, reactants must be in their proper orientation. Proper orientation or alignment of the reactant particles allow for effective bond formation during collision. Particles that are not properly oriented are likely to bounce back unreacted. Hence, no products are formed. Second one, molecules must possess enough energy to initiate a reaction. The minimum amount of energy that the reactant particles must possess to initiate the reaction is referred to as activation energy. This energy is associated to a hump in a path. For the reaction to occur, the reacting particles must possess enough energy to jump over a hump. Each reaction has its own unique activation energy. A large activation energy results in a slow reaction, while a small activation energy gives a fast reaction. How can we make the reaction fast or slow? There are factors affecting the rate of chemical reaction. These are temperature. If the temperature of the reaction system is increased, the average speed of the particle is also increased. This means that a higher temperature, more collision can happen. between and among particles with an energy that is sufficient enough to surpass the activation energy of the reaction. More collisions means a higher possibility for successful reaction, resulting in a faster reaction. Next, concentration. Increasing the concentration means increasing the amount of reacting species per volume. This increases the probability of collision between the reactant particles because they are closer together. Third, surface area. In chemical reaction, if one of the reactants is solid, the surface area of the solid will affect the rate of chemical reaction. The greater the surface area, the greater frequency of collisions between reacting particles. Hence, the faster the reaction. Fourth is the catalyst. It is a substance that increases the rate of a reaction by providing alternative pathway for the reaction to occur. That is, one with a lower activation energy. A catalyst remains chemically unchanged at the end of the reaction. Now, did you get the concept? Did you understand it all? Let us apply what have you learned by performing the activity 3. Explain the following situations based on your knowledge of the collision theory and the factors that affect the rate of reaction. First one, coal dust burning faster than a single lump of coal. Because coal dust have more exposed surface area while combusting, so it burns faster than a lump of coal. Next, hydrogen and oxygen react smoothly at room temperature in the presence of finely divided platinum. The platinum serves as the catalyst in the reaction, so that is why it proceeds smoothly. Third situation, the rates of chemical reactions approximately double for each 10 degrees Celsius rise in temperature. For every 10 degrees Celsius rise in the temperature makes the particles move faster, hence producing more collisions and faster rate of reaction. Fourth situation, milk sours if left out for a day or two, but will last 2 weeks in refrigerator. Putting milk in the refrigerator lowers the temperature of the decomposition reaction. Last, wood burns explosively in pure oxygen, but slowly in air which is about 20% oxygen. Since oxygen is required for a combustion reaction to occur, increasing its concentration yields to an explosive burn of wood. How was the activity? Is it fun? Now, let us know what have you learned from the lesson by having the short quiz. I'll be giving 5 questions. You have to choose the letter of the correct answer. First, which of the following statement is true? A. All reaction happens at the same rate. B. Solid reactant can cause a faster reaction than the liquid ones. C. Reaction proceeds at different rates. D. Catalysts are always needed for a reaction to proceed. Is it A, B, C, or D? If your answer is C, correct. Reactions proceed at different rates. Question number 2. Why do bakers prefer to use powdered sugar than black sugar? A. Is it more economic friendly? B. Is it more convenient to use for it melts easily? C. It is sweeter than the other one? And D. It is just the same. Is it A, B, C, or D? If your answer is B, you are correct. It is more convenient to use for it melts easily. Number 3. A chemical reaction with a small activation energy will most likely A. Proceed at a fast rate, B. Proceed at a slow rate, C. React at high temperature, and D. React at a low pressure. Is it A, B, C, or D? If your answer is A, you are again correct. We proceed at a fast rate. Question number 4. What happens to the particles if they are not properly oriented during the collision? A. It will proceed anyway. B. The reaction will be delayed. C. The reaction will need a catalyst. And D. No products are formed. Is it A, B, C, or D? If your answer is letter D, you are correct. No products are formed. Last question. Which of the following ways we increase probability of collision for the reaction to proceed faster? Except A. Lowering the volume of the reaction vessels. B. Store the reaction in the fridge. C. Use a stirring rod and mix reaction. D. Use smaller particles of the reactant. Is it A, B, C, or D? If your answer is B, you are correct. Store the reaction in a fridge. Have you got them all right? Congratulations everyone, for you did a great job. I hope you had so much fun learning today. Let me end our discussion today with a quote from Devasi Mira. Education is a chemical reaction between knowledge and mind. The byproducts are new thoughts, new ideas, new perceptions, and new feelings. That's it. Thank you. Until next time.